I think Austin was being very modest before. I will say that he is one of the few people in Washington that is both extremely smart on policy and politics. So if you want to get anything done in DC, please partner with CDAI. I'm Melissa Hopkins. I'm Health Security Policy Advisor at the Johns Hopkins Center for Health Security. I'm a lawyer by training, and I worked for 2 years in the US Congress, most recently as a tech fellow, specializing in AI and biotech for a senior member representing Silicon Valley. So I'm just going to show you really quickly the training compute of biological AI models over the years. You can see recently that the top model is ESM3. That's at about 10 to the 24 flops, which is just under 10 to the 25 flops that the EU AI Act automatically qualifies as a general purpose AI model with systemic risk. There's about 360 biological AI models that we're aware of. And this is from Epoch AI, shout out to Epoch. And so my main points that I want to make today are first, just like as a general principle, to future-proof your legislative text. Legislative text is very slow to change, but technology is very fast to change. So that means generally try not to put numbers in your legislation. That means do not put flops if you can help it, or do not put parameters in your legislative text. It's perfectly fine to put them in your regulations because you can update your regulations fairly quickly. And then also be mindful of what kind of models your legislation will be applying to in the definitions that you use. We found that a lot of the definitions that different policies or different guidances are coming out with, that biological AI models are following within the scope of those definitions. But then the ways in which they're saying to do things are not necessarily or should not necessarily be applied to biological AI models in these specific kinds of ways. And so I think as you're scoping policies, if you can carve out exemptions or carve out tailor your policies to be mindful of these three key differences between biological AI models and LLMs, you'll be able to future-proof your policies in appropriate ways. So the first key difference to be aware of between biological AI models and classic LLMs and other generative AI models are information hazards when it comes to red teaming biological AI models, or BAMEs, as we call them. So when you're red teaming an LLM, it's red teaming information that already exists. When you're red teaming a BAME, it's red teaming to see if it can create novel information. And so there are information hazards inherent in that that you might want to caution policymakers from advocating for. The second is that there are accident risks, biological lab accident risks from red teaming BAMEs. That comes from the fact that it's a little bit hard to do wet lab. It's actually hard to validate that there are inherent risks without doing wet lab validation from a biological AI model. And I'll have to look this up for my colleagues. Raise your hand, colleagues in the back. Thanks. So, for instance, my colleagues at CHS said that one can imagine designing new, comparatively harmless viral proteins with foundation BAMEs, and then optimizing their fitness and immune evasion capacity with narrow BAMEs, which would be concerning capability if it happened within a single evaluation or model. And so you could imagine that you would have to potentially take that and then do it in a wet lab to be able to verify it. And then similarly, that same example also applies for conjunction or linked model risks. It's very easy to take an LLM and then do one single evaluation of an LLM and say, yes or no, is it giving me a bad output? It's much harder to evaluate a biological AI model for a single output because of the fact that you have to link them with other models to be able to see whether the output can be linked with another model's output, and that is the thing that's creating the harm. So you'll have to be aware of that when you're crafting policies, because it might take multiple evaluations to be able to actually be able to identify the risk from a biological AI model compared to an LLM. And then finally, for biological AI models, we think it's actually might be appropriate to identify risks earlier in the AI lifecycle compared to in pre-development, compared to pre-deployment. And so it might not be appropriate to ask a biological AI model developer to do a pre-deployment evaluation if they've already done a pre-development risk assessment. And so just be aware of those kinds of differences when you're crafting legislation, and we'll be in good order for future-proof in the future. Thank you.